Yeah, you got to get recording. Hello, welcome everyone to another month of the Austin Python meetup. Thank you all for coming. I'll thank our sponsor, Antler, who lets us have the space here in person for everyone joining us in person. They are for, if you have a business idea, very early stage, they'll help you get your first investor. They'll teach you, some mentorship programs. They have blanking on the word right now. They have a program that you could join, and it's not an incubator. They have a like a 6-week program. Blanking on it right. It's not a boot camp. Wow, usually I remember it. It's a cohort. They have like a 6-week cohort. You can apply to join, and it's a group of a bunch of people. Some of them I've met a couple of them, fun people, but some of them don't even have a business idea. So it's never too early. That's the idea there. So shout out to them, and shout out to Vincent here, who's going to give us a great talk about Spotpredator. Okay. And with that, I'm going to hand it off to you.
Thank you, George. Okay, my name is Vincent. Today I'm here to present you guys a personal project of mine that's AI involved. And I call it an off-grid AI-powered early warning system for farm predators. And it's right here. That's the prototype I have here. Let me show to the camera so people on the camera can see it. This is the outdoor device here, and this is the indoor device. And just a quick, briefly description of the function of the device. There's two parts, as I mentioned. There's a field device here, and there's an indoor device here. The field device sits in a location of your desire near your animals, and it's solar panel powered, so it's free from your, if you don't have any power plug outside your field, you can use solar power. It doesn't require Wi-Fi. That's the main point of the project, because there's no Wi-Fi in my field. And it has an AI image model built inside a Pi chip. Runs locally, so it doesn't require any cloud service or subscription. And it's a rotating camera turret that scans 360 of the environment. I have all the single board computers and all the drives here in my bag, because just a few weeks ago I found a major flaw of the project, and I will show you why what's the flaw is. And so that's pretty much it for the for this project. I mean, not the end, but the description of this project. And I'm going to give you a background myself. I'm a software developer. Worked on mainly full-stack development. And this is my first time playing with 3D printing. Single board computers, all the drives, soldering, and a CAD design. So I mean, everything is new to me. I just started this year around March. Yes, okay, I should show this. So all this is just new to me, and feel free to tell me, give me a hint or a tip on something I can do better for this project. And so why I started this project? I have a farm. I mean, my family have a farm. We have animals like chickens, duck, and goose. And for the last 2 years, we've been losing more than 50 plus animals every year due to coyotes, hawks, falcon, eagle, and fox. And this is just some pictures showing the dead bodies, which I hope nobody's have a, trigger warning. Yes. And we raised them. We didn't buy the chicken. We hatched them too. So I do have some sort of close connection to them. So that's why I'm really upset to see them getting killed and every year. So I want to have something to watch the animals for me, and so I started the project. But before that, let me ask some questions. To show of hands, any of you have chickens and animals in at your home? Okay, 2. Or do you guys buy eggs for groceries? And do you guys remember this year we have this egg inflation early this year? And then what about dogs? Do you guys have dogs and cats that running in the field, like maybe small dogs like a Chihuahua and cat? So if you have those animals, they can be dangerous living out in your property because a larger predator like coyotes and fox, they do go for cats. And even eagles, they can go for your cats. And I have seen videos like that. And so we also have a pest problem. These are all pictures taken locally from my property. Opossums. We have a damaged attic and damaged fence from coyotes. We have ring cows in the attic, which took us more than 3 months to get rid of. We even hired people. And we have some wild animals like a falcon here on our tree. And those are just wild geese, but they might carry disease. And they can kill your birds if your animal gets passed on the disease, and you're gonna die. Which happened, one of our goose died after these 2 wild geese popped up from nowhere. And I highly suspect that they carried some sort of disease and killed our animal, but we don't know. So, and here's some statistics that might make this problem greater, so people care more. These are statistics collected from the U.S. Department of Agriculture. This is the total loss from animal killing or other disease, other kind of causes. So there's like $3.87 billion lost from just animal dying, and the number one cause. One of the number one cause is coyote attacking this pet, attacking your animals, such as the sheep, or goat, or even cows. And it's been increasing. The number is increasing from 3.5% to 11%. So this is not just an individual problem. This can be a greater problem for the whole United States. And it's a problem that can be solved. I don't know why. I'm surprised no one really tried to solve this problem, but here's a possible solution. And this is a lot of statistics I found on USDA from the Utah agriculture statistics. You can see coyote here at this line, 20,000 animal killed, 20,000 sheep and lambs killed in 2018, 14,000, 15,000, 17,000, 18,000, and 15,000 for these years alone. That's a lot of money lost. I'm just saying, there are solutions to fix these problems, but I don't know why they didn't do it. So here I'm providing a solution too. And at first I wasn't thinking about building this project because I was thinking I can just buy something, maybe just a smart camera. But a simple smart camera like within $100 range requires Wi-Fi. You had to pay for a subscription for cloud services and the AI services. Something more expensive like this stock AI cam is more than $1,000. And I wasn't thinking to buy like $1,000 machines just for my small farm. And but then the smaller smart cameras, it's not very loud because they don't reach out to my farm. They are off Wi-Fi after more than 100 meters away, and there's no power on my property, out in the field. So finally I decided, okay, I'm going to build something of my own, just DIY project. And there are also open source projects from other people. We had to use Pi4, and they have their own models as well. They still didn't work out for me because first, it's still more pricey because model Pi4 single board computers is like almost $100 or $200 now because the RAM price increased, and they still require Wi-Fi connection and the power outlet nearby. So none of the project I looked up on GitHub, none of them really match my criteria or requirements. So I started a project myself, and it is something, and it's completely, as I mentioned before, it's powered by solar panels. You use the AI model is built inside a Pi 02W, which the original price is $15. But right now, all the price went up. It's like $30 now, and they're out of stock. We can't even find them. So if anyone of you here knows a good source of, where I can buy the product for cheap, I'll be happy to know, because I need an extra copy of the Pi 02W for a super user of mine. So I want to do a lot of copy of this project for her to test. So this is the page for all the tools I used to build this project. Cloud and Cloud Code, I'm pretty sure everyone here knows. I also started vibe coding this year, so this is pretty new to me, and it's great. It saved a lot of work. I didn't know any of these things, but it helped me to understand, and it's the basic to start the project. RoboFlow is a website that's specifically for 3D, for image modeling. And Oceanic, YOLO, and the Colab, Kaggle are just the tools. Colab and Kaggle are just cloud services, free cloud services I use to train my models. And I'm going to tell you something fun. Well, not really fun to me, but maybe fun to you later. And the mega detector and species layer is two very interesting models you can use to save your progress for training for preparing your data set, image data set. And one is from Google and one is from Microsoft. Fusion 360, FreeCAD, Bamboo, P1S are the 3D design and the 3D printers I used. And the last is GitHub and Hugging Face, which everybody knows here now. Great source for image data set from open source models. And so how the system works, let me just take out the so the field device here is outdoor, and the camera is supposed to be in this, the camera is supposed to be inside this camera turret. I took it out because I'm building a new case right now. And with a motor, I think, I do have a motor. You can pass it around if people want to see it. There's a motor in the center. There's a motor in the device, and it was spin the camera around 360, and to watch your field. And then whenever you scan images every 15 seconds, that's a lot of reason why I only use the Pi 02W, because you really don't need a Pi 4 to do a live detection, because predators don't pop up that often. Maybe they come once or twice a day. You don't really need a powerful single board computers to do a 24-hour scanning. So a Pi 02W is more than powerful enough to do a 15-second scan intervals. And whenever there's a predator detected, the device will use this LoRa module, which is here, to send a message to an indoor device. And the indoor device will give you, a buzzer. There's a buzzer here where you alarm you. There's also a little LED screen here to notify you. There's a predator there in your field, go check it out. And this can be off Wi-Fi, but I have it connected to Wi-Fi because I have an email notification as well, which requires Wi-Fi. And it's not that slow. I mean, I do get my email within 10 seconds after detection. So I think that's more than enough time to react to an actual animal attack. And let me see. So here just a lot of quick workflow. It captures the image in the field. You scan 360 around and then detect locally, and just repeats this progress. Or you can even take the cover off too. It's very simple. You can see this is a rush prototype. I don't even have a mount stand on the wall to keep the pie on the wall. So. And there's a battery built inside too, and it's been tested. Okay, yeah. So here just some quick images I show you. This is an email notification, and this is the indoor device notification. You can see, whenever there's a predator detection, it will show you a text, and it will also flash, and it will buzz, and the email you will get what kind of predator it is, the confidence level, the time of the detection, and it's very basic. And the reason why it's LoRa module is because you can cover a range of 15 kilometers. So you can place this outdoor device anywhere in your field. If you have a large field, whatever, you can place anywhere in your field. It's power independent, it's automatic. It doesn't require Wi-Fi, so you can really place anywhere. And that's the advantage compared to the current smart camera you can find online. Yeah. 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 I have a peer-to-peer. So I have a lot of LoRa module in here. So it's just peer-to-peer connection. Yeah.
And which means kind of same protocol like static or mesh core, basically. Oh, that's it. Okay.
Yeah, I haven't known.
Check it out later.
Yes, I should.
Can you estimate the distance?
No,
Like the next thing is just like which direction and which distance, then you know exactly.
yes, I would like to. I thought about it, but then I thought about it, but I kept everything simple right now because Pi 02W after all is a very a small computer that can only run with small models, like a YOLO 8 nano, YOLO 11 nano, and I don't want to add more pressure on the system, which it did happen to crash the service. So I keep everything simple right now, and I'm going to slowly push the boundary later to see how much I can put on the this small device here.
Yeah, I don't even know if it would be as simple as just like what's the size of the detection box, and then which predator is it, and maybe that's just a rough distance estimate. Is that how that works?
LiDAR probably.
It can be.
There's distance, like how much space does it take up in the camera? If it's really small, it's a big predator. You say, well, it's far away. I don't know.
You probably estimate by the size. I guess you need to do some sort of like take two pictures like a second apart.
Yeah. Oh, should do a parallax on it?
Which would be even harder. But yeah, I mean,
If you had two, you should do parallax. That'd be great.
Well, if you got a encoder on your motor, you can see what direction this is, like north, south,
Yeah.
west.
Yes, that's possible. That's totally possible. And actually, I do have the motor position written in the code as well. It has 5 positions right now at the center, the left one, left 2, and the right one, right 2. So the image does record the image name does record the details, the location details, the time details, and the predator name type and the confidence level. So I do know all those informations. And
You probably enter the compass module at some point, and then you could just like. compass module.
yeah, the current motor drive doesn't support it doesn't have memory, so that's why. I mean, it's a $3 drive. You just all this together, including the camera and the solar panel, is less than $200. So if you just need if you don't need a power source, it's going to be less than $100 for sure. And that's a very budget-friendly DIY project. And so a lot of load on this project is this is just a vision, not a weapon. I don't want animal protection people, accusing me for, hurting the bio animals. So this is just a prevention system that, detects the predator and it tells you it's up to you to decide what to do after, after the predator is detected.
You got in the brink.
Yeah.
Just send a drone out.
Really, so the drone.
Yeah, I actually have the idea.
He's the cost saving, but I like it.
Yeah,
The thing is, you do have to be careful here in Texas, believe it or not, what down on the neck.
Yes, especially we do have, the white-head eagle and the bull eagle. You don't want to mess with them, otherwise, yeah.
I like the sprinkler idea.
Yeah, sprinkler or speaker, yeah. Which is totally possible because they are Bluetooth built in the Pi 02W. So if you can control, there's a timer, you can buy a timer for your sprinkler, and some of them do have a Bluetooth connection. So you can just, use the Bluetooth to trigger the sprinkler and then, scare away the predator if they are scared.
If you have like a guard dog, you could like have it call the guard dog.
Well, we used to have 4 dogs. They all passed away. We're not preparing to get another one. So otherwise, we did have less problem. But after our dog passed away, they all came and started hassling us. Yeah, I don't know what to say. So here, the heart of the project, the model, the vision model. If the vision model doesn't work, none of this is going to work. So as I mentioned, this is my first time playing with a vision model. And here, just a brief description, and maybe some of you doesn't know. A vision model is just a bunch of numbers, a bunch of mathematical numbers. You might think it's very complicated. It might be complicated to build it, to first build it, but in general, it's actually not that complicated. It's just a bunch of numbers, offset numbers. You pass on your image digit numbers, from all the pixel digits, and you pass those numbers into the parameters, and then it's the vision model is going to give you final numbers of the the confidence level of the class type. So it's really not that, you might think it's very, high advanced, high tech stuff, but it's not really that high tech. It's all mathematics. Right? And then there's a class, you need a class for your model to work, or else it doesn't learn anything. And the current class I have for this project is coyotes. Coyotes, what was dogs, and what was the other?
Predators.
No, the flying birds. That's a class I call it. What's the class? Like hawks and falcons, those kind of class. And you just train your data set, images data set, like thousands of images data set, to to teach the model to to understand the label. Especially for object detections, there's annotations, boxings. So the model learns that range of the numbers, which covers the animal, the predators, including the color of the digit, the what do you call that? If a lot of object detection models, they watch the
Shape.
edge define the edges, yes. Forgot that moment for a moment. Yes, and the colors. That's the main, pretty much the two main things they use to identify the differences between each class. And that's pretty, that's very, that's the general idea of a vision model. And here's the first model I used. I didn't train it. This is a ready-made model trained on COCO data set, which some of you might know. COCO is pretty popular, a large data set that includes more than 80 classes. I can tell you straight away it didn't work because it didn't include chickens. It didn't include coyotes stuff. This is just more for maybe for cities, for cats and dogs. And here are the two cats we have, barn cats we adopted. And why this fell? I mean, first, it didn't have the class I was looking for. Second, every time it detects a chicken or a dog, if I try to approximate that chicken or dog into some other animals, into some other classes, so it's giving me false positives every 10 seconds. And I know right away this model didn't work. So, and from this point on, I pretty much think, okay, I need to start to build my own model. I mean, I trained my own model, not to build. I didn't build any models. I just trained them. And so the second model I use is a classifier model, not object detection model, because I was try to keep things easy, minimal. You just classify, this is a predator or not, that's it, a chicken or not, and this one actually trained. I have my own data set, but it's not a good data set. I just downloaded data set from online sources like Hugging Face, from not from Kaggle, from
Use agriculture data sets.
from MobileFlow. Yeah, as I mentioned before, MobileFlow is professional in building vision models. But I can tell you, there's one major flaw with MobileFlow. I'm going to tell you so you guys don't make the same mistakes as I did. So these images, I'm telling you, they're not going to work because they are in different domains. They have good quality images. They have bad quality images. They have live vision images. They have all sorts of kind of images that might not be related to my Pi camera 3. It's on the cheap side. It's like a $20 camera, so it doesn't really take a really very high quality images. And so this is funny part. The model actually failed, collapsed, but I didn't know that. I mean, it's my first time, training the model and deployed in the device. I left the device out for 2 weeks. It was silent. It wasn't producing any false positives. So I thought, okay, maybe it's working. And I didn't get any animals killed for those 2 weeks. So all the coincidence happened. And I just left the machine out. And one day I just finally realized something. I said, this is not making any sense. It's so quiet, for 2 weeks. I didn't get any alert, there's no, I started to have bad feelings. And so, oh no, okay. So I took the machine, I took the device in, I tested the model myself with, images that wasn't trained. It was producing background 66%, poetry 23%, and predator 10% for every single scan. So at that point, I know, okay, this model totally failed, and I was wasting my time for 2 weeks without knowing it. And this is the point where I learned I need to do more testing before deploying the model and deploying the code. And so here's my model 3, the right kind of model, the object detection model. And the classifier model wouldn't work because it works best for one kind of label at the time. But I could have chickens, duck, and goose all showing up together with a coyote in between them or a fox in between them. So whatever the label has the highest confidence is going to show up, which can be a chicken. And then you will not tell me there's a coyote or not. And so I had to, after speaking with cloud and cloud code, so I said, okay, object detector and object detection. Object detect model is my next model I'm going to train on. And here is I actually lost which model I used. I believe it's also a YOLO model, maybe a YOLO 5 or YOLO 6. I'm not really sure. But this one didn't really work as well. I'm going to show you why. But before that, I'm going to show you something else I did. From this point on, I learned that I need to have a more validated data set, a training data set, a validation data set, and a test data set. And you can see the 70-20-10 is the proportion of each those for each those folders. And this proportion is used to, and that's a classic balance I learned that, you want to have for each of your class, you want to have a balanced amount of images. So the model doesn't prioritize certain class over the others. And this is part where I spend 80% of my time is manually labeling each images. Blind, you have to repeat this every, for all the images. You go through and box each of the predator images in the picture, and including the chicken images, the duck images. And last is the heavy logging I learned. Actually, in the beginning, cloud wasn't. I guess I was using Opus. I think I was using Opus 4.6 or something. It wasn't doing any testing for me. No logging, no logging. So that's why I didn't know the device was having errors. And so at this point, I learned that I had to do more logins. And then this is where I started to have an email report as well that gives, send me an email that's error happening. And that's the LED will also tell me there's an error, like maybe a battery error, a camera error, maybe the LoRa module is not connected properly because I have it's hot swap, they do come off easy. So I have all the error check this time to prepare myself for the future. And as I mentioned before, the data set is not good. I call it Frankenstein data set because it includes all sorts of domain. This image here is such high quality image. The feathers and stuff are all well defined, but the actual images are like this. So you can see the differences. Your model is not going to do well.
The difference between the engineers and the data science.
Yes.
It's
So
because of the camera, like one thing you said you found that there's like a lot of if you try to train your data set on images that are taken with high quality,
Yeah.
but then your camera is like
low quality.
low resolution.
They're not going to do well. Just can you say that? Yes.
Downsample those images to the same so that they match it up.
Yes. So this time is better. Still better than the first two models. I still have lots of false positives and 0 true positives, which I can't control because I can't control when the predator come or not. And they call this domain mismatch. That's the term I learned later on. And here are more images. This image is taken from my phone, and this image is from the camera. There are slightly differences, but I think these two are okay in general. And here's a lot of images. These are images you can get online, and this is the images. You see there when you get in, public source images to train your model, the quality of the domain varies a lot. One is very blurry, one is very defined. And that can really mess up your model. It doesn't train your model well. And so my first try, the model 4, which I believe I use YOLO 8 Nano. I have a better source image here, LiDAR Science. They do have a public images you can download, like hundreds of thousands of predator images you can download. And GBIF, I believe, is a global biodiversity institution facility, which they also shares a lot of wild animal images. They are taken with trail cameras, so they are similar image quality as this Pi camera 3. And I also learned to do domain adaptation, which this is a lot of time I learned to downscale high quality images for the model to train for all the. At this point, I downscaled all the high quality images to match the quality, the image quality of the taken by this camera here. And okay, here's the good stuff. Mega detector. I don't know if any of you know mega detector and species layer. They are AI models that helps you automatically label your images and boxing them.
Yeah.
So you had just no more grinding. I mean, pretty much no more grinding. You still have to review your code, review your data set, but they do all the jobs for you. They do the boxing, and then they label the animal in the box for you. So in the coyote stuff, we know how big Google and Microsoft is. They have such big image data set that so this is. And you can use this on your local computers as well, which I did use on my local computer, and they run fine and pretty fast. I think for 3,000 images, they only took less than 15 minutes, which is great compared to reviewing 3,000 images by yourself, hand by hand, takes 80% of my time, really.
When you're doing testing,
Yes.
it sounds like you would iterate on a model, then stick it in the box, and then send it out there and then wait.
Yeah.
But if you would have probably would have been faster if you start by just using that crappy camera, just record a week of footage, and then take that back to your home station and just test every model at the same time.
I did that.
Okay, you did.
I actually did. I have more than 50,000 pictures on my computer right now. But the problem is, I don't need that many background images. When you have the device out, it's going to take thousands and thousands of background images of your dog and chicken and stuff. So that's not enough because my goal is to.
How many hits do you how many hits per week do you get of a predator?
I don't know.
Okay.
You don't know. Yeah, I just this.
It comes in spurts.
Yeah.
Yes.
Like right now, it's
We
quiet.
just this weekend, Saturday, we lost a lot of one, a coyote camp, while my machine was then, down. So I didn't even get the images, and I lost a dog. So which I was really upset. There was a coyote right there, out there, and I didn't get the image. I was
And
really
that came in the afternoon.
yes, right around 7 p.m. or around this time. Yeah, around this time actually.
So
Yes.
you said this model you're using, this model, what it does is it draws a box and it kind of labels the species for you. So why don't we just use this one?
Because it won't run on these small computers.
Okay.
This problem can easily be solved with thousands of dollars.
Yeah,
of
that's the
horsepower.
point.
Yeah, if I buy
Just in that now. It's 250.
I think the goal here is let's keep it cheap because a lot of people can't spend.
yeah, thousands of dollars just to just this
So
is
just for a $10 chicken.
yeah, $10 chicken. Yeah. So and it's just on my personal project. So I wasn't really preparing to spend $1,000 to just buy a high-end GPU to do all sorts good stuff. I wish I can, but no, I didn't. Yeah, I thought about it, but as I said, they're not going to run on this small device. So let's see. And here's finally some data, statistics data. The overall accuracy is 92.7% for all those classes in general. Here it's bad because you can see the fox is only 69%, which I am still working on the fox image data set. I believe there must be a couple of the bad images that's seriously corrupting the training process. And but in general, it's working fine. Yep.
Oh,
What's MAP?
That's the mean average precision. Yes. And most of people just look at these numbers because this number is very strict. It's tests between the range of 50 to 95% confidence level threshold. So at this point, I only set up my threshold to 80%. Anything above 80%, you will alert me for now. And it's been doing okay. I still get like a couple false positives a day, but not enough to annoy me. Yes. And the record is just how, if there's 10 predator appeared, yeah, 8 out of 10 times you will detect that predator. And so this is some true positives I can show you. This is one of the, I believe it's hawk at this image. Oh, raptor, I call it raptor class. It's only 62% because it's a very distant animal. And here is a falcon family class called Caracara. This one doesn't have label. This is because it's the earlier images that I forgot to save the one that save images. They have a version that including the boxing, and one version doesn't have the boxing. The one is the boxing. You use it for training because when you're training, it doesn't want the boxing in the image. So later I had to save the images into 2 different folders. One is boxing, one without boxing for training and observation. So I'm finally getting some true positives for Model 4. And here's the email, a report, daily report. You can see all this, the reports I get per day. The time, the type, and the confidence. Most of this is just false positives. To be honest, it's just false positives. And that's something that I'm still working on. And there's a balance you have to make. If you set the confidence level too high, you might miss a predator. If you set it too low, then you might have like 60%, 60%. Those are false positives, likely false positives, or animals in a range that the model is not very sure of. And now, but still, Model 4 is a major improvement compared to the previous 3 models. And the number is not that bad actually compared to I have a 10 false, maybe let's say 10 detection out of almost 3,000 total scans. So that's a very small number.
How do you know it's false positive if you're not saving it?
I have the images.
Oh, you did save
I do have the images. Yeah.
He pulls them in.
I post every night. I post them in and check the image one by one.
So it does store the image when it takes the photo. It just doesn't transmit the image.
Because I'm using a LoRa motion.
Yeah.
So LoRa is good enough for messages, text messages, but you can't really send images. I wish it does, but it can't.
It's like, I've always had this idea with mesh tasking lawyers, especially with AI. It's like they're very good at like compressing information.
Mm-hmm.
But like, can you regenerate on the other side? Maybe you don't need to. Like, maybe you could send just like an embedding of that image, but then the model that does the embedding.
I tried.
I have an autoencoder.
I actually have this idea too. I
Yeah.
tried it myself. You can still take a 15 minutes, even if you compress the image into like not you compress, just make an image very tiny. It's a small resolution.
2,000 float.
I mean, 15 minutes
He's
is.
saying make it into an embedding, not compress the image.
Oh, okay.
You actually
Yeah,
create an AI embedding of it, a bunch of numbers.
I don't know. I don't think that would work too well at your scale, to be honest.
Yeah, I'm not sure.
Well,
Maybe I can
it's
try.
an
The
interesting
compression
idea.
it could learn your farm,
Mm-hmm.
right? So it can basically highlight what's out of place and ignore like that box has always been there. We're not going to store that.
That's a
good
good.
way to do that. Yeah.
Yeah,
Yeah,
that's
that's
actually
that is just not similar. Like,
Because I think like maybe an autoencoder would do a pretty good job with that.
that's a very good idea.
And if it takes 15 minutes, that doesn't sound bad. Like
Well, you will sound bad because the machine lab is still running. And while you're running a lot of, let's say, AI, model and separate tasks, you might pressure the CPU and the RAM. And, might crash one or the other services. I don't know. I mean, it did happen after I did all the logging and all the testing. It did crash for once after 2.5 months testing. So I don't know how much, again, I don't know how much I can really do with just this single board computer here.
But if you actually like, in a business setting, you could enhance it so much without improving.
And maybe I
hardware.
just, it's just the basic model. I can have a medium, higher-end model and a higher-end model for people who wanted to spend more money. Yes, I can totally do that. Yes, that's a good idea.
Vincent, I have problems hearing what's happening in the other room. It's a little bit muffled, whatever we're hearing. But did you consider doing something like auto improvement?
Auto improvement, like what, like online learning or like what? What do you mean by, what do you say, continuous auto improvement? I don't even know.
Yes. So think about it. You don't want to spend a lot on the small device. That's got it. But then again, you can offload it to a computer, and you do have the every detection that you have, and then you can have a stronger model, like an AI model that you actually pay for to actually go and detect things and say false positives, negatives, whatever, and then retrain the model using those images.
I did. I will show you my next slides.
Ah, okay. Sorry.
No problem. No problem. Yes, it's good tip, which I thought about, and I did use it.
Engineers think alike.
I got a question for you.
Yes.
Is there any feedback to the motor when you did a detection? Like, do you just scan around and just take?
I thought about adding after the detection, the motor doesn't move, or is try to maybe. Well, currently it doesn't. Currently it just 360. Even after detection, you must still go 360 because you don't know. You can't. I don't have an AI that predicts where the predator is going to go, maybe left and right. But I have an idea that if the AI is not to reduce false positives, I can do a second scan that maybe at the same direction, or maybe maybe more left, maybe more right. I have no idea how to do that yet, but maybe just the same direction and do a second scan to confirm the chance of the predator.
Yeah,
I can totally do that. And yes, that's actually my idea on my note. And yes, that's a good tip.
And Vincent, if you're doing this, you might want to do one more step.
Yes.
Train on fake images. Today, image generators, you can actually get ones that actually will run on your computer and generate images of those predators. And then you can run on them. Just extra data, free.
You mean using AI generating predator images?
Yeah.
Images?
Yeah, you're looking for predators. So
Yeah.
predators.
I just don't know how well it's gonna do because AI.
Your background.
We don't know as well, but it's another idea because they have much more data that's free.
I will load that. I will try that. Maybe that will save me time, so I don't have to go look around for images. So okay, so images. Okay, letting. I remember Chachi. Oh yes.
So I don't know if you're going to talk about this later, but I noticed all your images and training were done on nice sunny days.
The images were trained on nice days.
Nice
What-
sunny
weather.
days. What about?
Oh no, they do have rainy days and the cloudy days. I have.
So it's secret.
Yeah, it just happened to have a.
Predators like nice sunny days.
No, you'd be surprised.
Not gonna see a lot of raptors.
Last year, 50 of animals were killed right after rain. Yes, they came right after rain. These animals, they know human patterns. They observe human patterns. They know people don't go out in the rain. So every time it's raining, I have to go out to check.
So, can your system see in the dark or?
No, because the camera is not for live vision, and I did look this up. If you have a live vision camera, you need a separate class for live visions separately because the model doesn't handle that well.
I just assumed if it's chickens and geese, they don't stay out, they don't go
Yeah,
outside.
because we do close them up in the barn at night after 9 o'clock. So that's why this system only works from 6:30 to 9 p.m. And it's been doing okay. That's why I didn't need a live vision camera. I didn't think it was necessary unless, but we can add that. That's maybe slightly more costly, which is totally fine. If people in the future people want that, that's an option. Okay, here's another trick, a trick I thought myself, but then later I find it's just a technique people already discovered. So my current image, the image scan I have is the resolution is 1920 times 1080. And but the problem is, you can see more than 40% of the images are just skies. And you don't really need that. I mean, we do have hawks and the falcons, but they're in the sky all the time. You don't want false positives just seeing them. You want the device to alert you when they're near the ground. So I cut off 40% of the top images, and then I separate them into 3 tiles, left, middle, and right tiles. So each of them now is 640 times 640. The reason why I did this is because this actually helps the model to train on predators that are small and distanced. Before, the model is best at the 10, 20 meters range. Right now, you can go up to 40 meters. So this is a technique I thought myself, but then later I just discovered people already know this for sure. I mean, for sure there are smart people that discovered this already. But that's a technique called pre-processing, and that's patch-based inferences. You know, they already have these techniques out there. I just didn't know. Yes, after increasing the scan, you know, now instead of 1 images to the model, you're sending 3 tiles of images to the model now. So you're building the pressure for the Pi02W, and I think it's overheating the single-board computer right now. It's still working. It's still working. It's not crashing really. I just don't know how much further I can push this single-board computer. And it's just
Like, what are you using to inference the model from on your, like, is it running, like, how do you call the model? Is it just through the, I don't know.
I mean, the YOLO model is the EF,
It's like, that's right.
TensorFlow, yes, using TensorFlow Lite.
Yeah, yeah.
And I just have images like a JPG images, you know, 640 times 640 JPG images. One image was fine, but then 3 images is starting to be a little slower. So that's something you have to, you know, balance out. You know, you want more scans, but then you risk the chance of, you know, the stability. You know, stability of the device. You know, you don't want the device to crash middle of the day and then, you know.
Oh, have you heard about the Coral TPUs? I don't think they sell them anymore.
A lot of, I think I heard them. I looked up. Yes, I tried to look for a lot of alternatives. You know, banana, orange, all those. They say they're supposed to be cheaper. They are not any cheaper really, right nowadays. Yeah.
Is JPEG the best file format to use for this kind of thing?
Actually, you'll be surprised it is not. It's actually probably one of the best. PNG, JPEG, they use them to train and all the models. Yeah.
That's cool.
Even if you download image data set online, they all use JPEG too. So, yes.
Do you work on the color images directly, or do you do any data pre-processing? Because you can convert them into binary. There's a technique called MVP, local binary pattern, and that's one computer vision technique. So you can get more information out of your image instead of, you know, cropping the image and taking 3 tiles.
Do they work with the model?
Yeah.
Like you can change those binary.
Yeah, before calling the model, you can actually get more info,
Mm-hmm.
and you know you can can train much faster, I believe. Because grayscale is much more faster than color images. If you say, because model gets confused with the colors.
Yes,
But
they do.
with grayscale and binary detection, you can convert it to zeros and ones. You know that.
Yes, but I thought the model already does that because by now the model is taking the image, the digit from each pixels, turning them 0 to 1s, and then pass on into the parameters.
Yeah, this one is more of a pattern.
For patterns.
Yeah, neighborhood patterns. If you can look more into it, it's a bit complex, but it's lightweight. So it's
lightweight.
LBP, yeah.
MBP?
LBP.
LBP.
Local binary pattern.
Local binary pattern. Okay.
Yeah.
All right.
It may or may not work, but that's what.
That's good stuff. I will check it out. Thank you. Thank you.
A lot depends on your domain. So if you look at an image and your predator is kind of blending with the background, color may not add, but if your predator is different color than the background, you don't want to lose that information.
That's true. That's true.
Those are always trade-offs.
So yes, so it's just like a trade-off here. You want more scans, but then you trade off something else.
Whereas like because the color things are robot mode is a coyote.
A fox. Anything orange, you thought it was a fox. No. That's why I think the fox class is having some issue. Yeah. So Model 5, okay. This the more, okay, here's the stuff Jacob mentioned, the hard negative mining is the one you use the false positive images and the true positive images are connected on the device to retrain the model. They call that hard negative mining. And I also cured duplicates. When you download data set from online, sometimes people just upload duplicate images, and duplicate images does your training process of the model. Downscaling per image was the other part I optimized. Before I was downscaling the image, all the images. So now I do them individually, one by one. So each image is downscale, to match the current domain instead of just a general, the scale of the resolution and stuff. Also removed light vision images. Looking through thousands of images, you can't remember all the images you reviewed. It's actually very difficult to memorize. That was this image, there before, or so it took me like weeks to go over the data set, to pick out the images, to move them, to optimize it. And yeah, that's what I did for Model 4 and Model 5. And Model 5, I used the YOLO 11 Nano, a better version of YOLO 8 Nano. And here's a new, this is just my statistics for my data set. There are right now there are only 700 images for coyotes, 650 for fox. Maybe that's a lot of reason. 845 for raptors, and around 700 for the lake tips, the backgrounds. So the total is around 3,000 images. And the ratio is about correct, I would say, around near or 20, near the 25% ratio, which is the what you want for training your vision models. And here's a performance statistics, improved performance. Before it was 92, now it's 93, slightly improved. And even for the Fox class, it was slightly improved too. Still not ideal. I'm still working on it. But 93% is actually more than enough to do the job. You'll be surprised. 93% is more than enough to do the job. And yes, here is just you can see only 4 false positives now daily, around 4 to 5, maybe sometimes even less, sometimes no false positive at all. And FP16 quantization is just the size of the model. Because I'm running on a small pi, so I use a small model, FP16. They do have a integer 8, which is even smaller, but it's really not necessary. FP16 for this YOLO 11 is only 5.6 megabyte, I believe, which is pretty good for to run on the device locally. And so, but here's Model 6, and this is the reason why I have Model 6 is from some suggestion from other people because the license issue. I left about
Jacob?
yes,
Oh.
Jacob, yes.
I smelled it in a minute.
Yes, last time I was here, and Jacob mentioned right away what licenses I'm using. Pretty much all the YOLO models use eGPR 3.0, which is not, they say it's not really business friendly. So after I learned that, I said, okay, I'm going to look for something different. You know, I find a pickle detection small. This is a small one. And it has a license of Apache 2.0, which is more business friendly this time. I'm pretty sure most of you knows the differences between the two, but AGPR is kind of less and Apache is permissive. And I mean, right now I do have my code in open source right now, including the models. But in the future, maybe we want to have a much better models. I might not have an open source or not. I don't know. You know, if I want to, you know, make this into a business idea. That's why I changed to Apache 2.0 for now. And there's a lot of challenge for this model is for this specific model is that you only train on a GPU. You can only train it with GPU. So I couldn't train it locally on my MacBook computer. And that's why I had to use Colab and Kaggle, and the funny story is here. I left the training on Colab first at night. I have a free service account. I didn't pay for subscription. The next day I woke up expired. You wipe my files, so all the hours of work is just gone. And you can't get them back. You know, they just wipe them. After the session is over, they just wipe them. So I had to change to Kaggle, which is they save your files this time, and they do share. You know, they let you also, you know, they also have a GPU, what T100, I believe it's like T100 GPU, which is good enough for training. But still, for any of you who want to use cloud service like a Kaggle or Colab, set up your environment, save your files before you do anything. Otherwise, you might lose your progress after you wake up. So, and here is my new performance. It's not as good as YOLO. I mean, it's because pickle detection is a 2 years old model now. They didn't really update it that much. YOLO 11 is more newer models. Maybe it's better, you know, accuracy and stuff. So it's only 2% differences. You can't really see the, you know, local performance wise, you can't really see the differences. So it's still working. And I didn't spend much time because I already have my data set prepared. And just a quick code, you know, review. I'm not doing much because I didn't really write any new code. I really appreciate the coding communities, you know, people sharing all the packages on GitHub and stuff. That I don't really have to write any new code myself. I just have to, you know, use the methods, use the functions online. I can find and let the AI do the job for me. And I mean, as my experience with vibe coding is that it teaches me something quick, especially pass me to the basic phase quickly. You know, I start to understand the soldering part, the wiring, I didn't have to set up my environment because the cloud code just set up my environment for myself and for me. It tells me what I need. It even tells me what kind of pipe chip I need, what module I need, what kind of LoRa module, the RTC, the real-time controller. It tells you everything, you know, because there are other people who have similar projects. So I actually didn't have to search online to, you know, to see if, you know, which component to buy. And but there are problems that I went through, and you know, it took me weeks to learn that. First advice I got from Cloud Code was that I should use 50%. I mean, 50% of my data set should be background, That's for model 2, and that's why it collapsed, because too many background images, and that's why you can see that 66% background images results for all the scans, because you just simply have too many background images, and the predator images just pretty much mess up the training process of the model. And later I went to ChatGPT and RoboFlow. They say you should only have 5 to 10% of your data set as background images. Sometimes higher, depends on how complicated your background images are. A lot of mistakes that you made with 3D models. You'd be surprised with today's how many people working on MCP servers. FreeCAD. One of the MCP server I'm using is called FreeCAD for FreeCAD software. You can basically tell cloud code to design your model for you, but it's not that good. Not there yet, I would say. It's messing with the numbers, the parameters. It took me, just printing the cover like this takes hours and hours. And if you make one mistake, all the time is wasted. The material is wasted. And yes, you have a question?
I have a question for you, maybe just for like well, have you ever used like the open scan? Is that what it is? Have you heard of that?
You mean like scanning the?
No, it's like it's 3D modeling, but it's like a programming language for it. So like you can define a cube, and you can like subtract from the cube. You define another cube, subtract from the cube. And I've never really used it. I was wondering if anyone else does. But I feel like I feel like AI would be really good maybe with that.
Yes, for the basic shapes, it's great. It doesn't make any mistakes. For something more complicated that I'm trying to design myself, then you're starting to have issues. I can give you a quick example. You all know that I don't see one here. Actually, there's no surveillance camera here.
Oh, it's smart.
Yeah.
Probably in the wall socket.
Yeah, I don't really see it right now. Some of the surveillance camera you see out there outdoor, they have a cover. They have a hat to cover to cover the lens, from the rain and stuff. That the AI couldn't do. That's a curved shape like that. You couldn't do it because you couldn't get the position. You couldn't get how much the curve I want, and curve seeds.
Well, that's not a farm. You should have made this out of wood.
I mean, you'd be surprised. This is ABS materials, so basically just like a lot of keyboard materials using at your home. It's been tested outdoor for 2.5 months in the thunderstorms, in the high heat. Right now 90, 100 degrees, it's fine. It's not melting, it's not warping, and the inside temperature is okay. I didn't have any fan inside, so but it's still working. So and I will tell you later. I have a different design, because I found some major flaws. And so yeah, that's my experience with vibe coding. And this is just a simple code. The crop. This is the crop and tile trick, and it's very short. And the Python. That's all I had to do. Just this simple code here. If I improve the performance of the image training, and just how amazing, just few lines of code about different result. And here's just a pro code. I mean, I also showed this to a pro community from just an email that you put. That I wrote. I mean, not really I wrote. I mean, I made some changes, but the AI wrote it for me. So I can't say I wrote it. I mean, I changed and I modified it. And there's not really much coding because all the code AI pretty much wrote all my code. I had to be honest. I just had to make some changes myself to change the dependency requirements, to change the configurations, and some of the. I remember he had some trouble with path files and test files, but that's something not that important for now. And just some 3D tips I have as a beginner, something like this, I showed you guys saw before. This shape has to be exactly center for this, for this camera turret to rotate it, in the center, or else it's going to be crooked. This the AI couldn't do. It took forever for the AI to calculate the amount of space in between that where I should place the motor. So I had to do this myself. And even just by a millimeter change is gonna, mess up the print, and mess up the whole thing. And a hook that I still don't know how to do. I'm still learning. As you can see, I didn't have any screw mount on the wall, which I do have right now. That I don't know how to show it with my pad here. Yes, so I'm just, I'm still working on myself, learning on the, 3D design myself. And something very important before you print, learn your filament type and the properties, because sometimes they work, the default bed temperatures and the print temperatures are different for each materials. And you might waste your time printing something and they just end up warping up. Just like the wall here, I have the first couple times, you just keep warping the side or warping the center. So I just, did I not mention it here? Oh yeah, I have it. And you want to print something small first, so you don't waste your materials. You want to make your model small, small pieces. And there's a lot of funny stories that was a blackout. And it was more than 80% done. But then after I woke up, this board just came off. So it's not in position anymore. So I had to redo the whole print myself. And that's a setting I can tell you that will fix the problem forever. And these are the tools I use, Fusion 360, but I'm telling you, Fusion 360 didn't work well with Apple Silicon. Yeah, there's stuttering issue and really slow. And there are limited amount of documents you can create for free users. Like you can make 10 documents and that's it. So I use FreeCAD open source. It's open source software, and you also have an MCP server that's working for the FreeCAD. It's doing pretty well. I show you here is this one here. It's basically the same, but it does have a lack of features compared to paid softwares. And a lot of I mentioned the MCP tools. You can look up online. People are crazy with MCP tools now, and you can pretty much find any tools you need online. With for AI and AI. Okay, yeah, here's a tip. I believe for all the printers, they do have this bring the web settings you can do, which is just basically a layer of filaments that attach you to your object, and it will stick to the bed. So now your object wouldn't be warping after it cools down. So this is very important. I mean, so I stop having all the warp issues. And yeah, as I said, I use ABS materials, which requires a higher bed temperatures. Otherwise, yes, also easily to warp. That's something I just learned by from mistakes. Okay, almost end. This is a scoreboard for the project. I mean, the advantage of this project, as I mentioned, it's solar powered. It's 553, no subscription. That's HAI building. Field test proving for 2 months, under also weather conditions. It's fully open source right now. That's the limitation is the range. Right now, its maximum range is around 40 meters. I know some people might want something further, and it's localized because you train your model. I train my model on my farm's images. So if someone else wants to use it, they have to retrain the model themselves. That's the problem. That's one problem. People who don't know AI or who don't know computers, they don't want to know how to do this themselves. So this might be a business service in the future. It's daylight only, and I know some people might want to do it for light vision, for shapes and stuff, because some farms, they have shapes out, they have guard dog and stuff, so they don't really show the animals into a barn. Might not sustain in the woods because the woods might cover up the angles of the view. So the animal, the predators might go behind the woods, go behind the trees, and then the predator is not going to be able to detect that. And the woods might also block the sun for the solar. Again, might not work in a complex environment. It's reactive. It's not preventive, so it doesn't really stop predator eating your animal. You have to do something yourself after you get notified. Right now it's scanning 360 every minute, so I think that's good enough. I didn't think this really had to be a disadvantage. I think a minute is more than enough, and then it's missing a UI app to allow the users to configure the settings, the time of the day this thing is working, the angle of the camera. That's something I'm going to work on after I fix the case and the model. And this is a new side idea to share with you guys. We all know GitHub's share codes, Hugging Face share data set and models, but there isn't really a website right now that shares just images. And I mean open source images. So this idea is to build a website for people to share and to use images like a predator images, any object images they want. It's a filtering system that has tags, very detailed tags like animal types, the camera type, the image, day of the time of the image taken, if this image is a live vision image, if the image including live or dead animals or like just dead object, if this image is there's some other tags that I want to add, so all the users can just filter through all these tags and find the image exactly they can use right away for training the data. So they don't have to go to an online source like I did, which I spent a month and a half to keep going online and looking for images. So yeah, this is the idea I have. I don't know. I mean, it's gonna require some staff funding to have a server to best store images. And people who use might end up like a GitHub where people can share their predator images, object images, and the rest of the other users can use, and then they all share, and then they use and share and use, then it becomes a community as well. And so it makes because 80% of the time is training the model, connecting the data set to train the model. Training itself, it doesn't take that much time. It's all pre-programmed. You just have to wait for a half day or a day. But the data connection is the time consumption part. So I was hoping maybe a website or some sort of that gathers these images and share them as a public source for other people who are interested in training their own models. Just like GitHub and Hugging Face.
Vincent, I don't know if you know, but there are platforms for sharing images, many of them. Again, look at the license. There are those that actually allow you to share images under CC0. So look for those. There are many, many platforms that give all sorts of images. And today you can generate images using AI.
I have a test the AI generated image. I don't know if they're gonna work or not. I haven't tried them.
It works, and there are models in Hugging Face that show you how to do it. There are variations on Stable Diffusion and Flux and all sorts of other models like this. If you want to just put in software, try down a Comfy UI. But again, check the licenses. Not everything you generate you're allowed to use. So,
okay, I will try that out for sure. That will save a lot of time. I mean, if that works, then I guess this idea might be just chopped. You have a question?
Oh, yeah, just for your tool here,
did
you think about adding a microphone?
You can add a microphone. Yeah, speakers.
You could train it.
I actually had a microphone before, but then it just got disconnected from the. Also, I just moved it for now.
What do you using the microphone for? I just think.
Mimic dog noise, like a barking noise,
No,
or
not a speaker, a microphone. So you could hear your chickens.
you talk a
give like
microphone.
Yeah, so if your chickens make a distress call.
They do make a quick distress call. I know chicken do make quick distress call.
That could be another AI thing.
They have that. They actually have this idea. I see the models like this online. I thought about it. I remember there's a problem. Is the first your microphone has to be sensitive enough to your animals, and this device is pretty much sitting in the middle of your field, or like near middle of your field, so you can watch all around. So when the chicken make a stress call, might yes or no touch the that
I
call.
Engineering problem.
Yes.
Also,
So
when it's the far away stuff, does the camera have a variable focus on it, or?
I turned it off because it's messed up. With this that's autofocus. You're talking about like
Not
autofocus?
autofocus, but just to say like, okay, well, we'll take it at 60-meter focus, and then we'll take another picture at 100-meter focus, and that might make it easier to find the far away animals.
I thought about that. This one didn't work with further distance, like focus. Maybe a high-end camera will. I should try that idea. I should spend more than a week to play with the settings of the camera. But it didn't work for this camera. And maybe it's just not good enough. Or maybe I think I'm missing some stuff. The settings I didn't play correctly. So yes, that's a good idea too. But when do we do the focus? That's a lot of question. When do I change the camera focus to take an image that's focusing on something smaller, further away? And when I change it back, who decides that?
Be part of the traverse algorithm. Every time it turns,
Then-
go far, go close, turn.
So
far, close.
that means more scans per interval, and that means more stress and the ball, and more stress and the ball means a likely issue of crashing, freezing, which something I will push later on to see the boundary. But right now, I just want you to work as a stable version for now. But that's the idea. I had that idea in my mind, but something already didn't work. So I said, oh, maybe I shouldn't push it right now. And yes, so this is my project. I mean, I don't know if any of you are working on your own DIY projects. I mean, I think it's someone I can do, something I didn't know anything about this. You can do it too. You can see I have a very bad soldering on my Pi because I didn't use flux. I didn't know how to use flux, so this didn't stop me. I just continue, push on the project. The model fails. I still push the project. I couldn't find the right data. I just keep pushing on, and I said, I mean, with AI today, I think that almost anybody can do something on their own at least to start something, and to get something started. And so, yeah, that's it. Oh. Okay. Oh, yes, sorry. That's a having face space I created. You can play with the model. Yes, you can play. You don't have to download anything. It's on browser. You can take everyone the image. I can show you right here. So yeah, I tested myself. This is a fox. You can see it's even at night. This is pretty much at nighttime, and we're still able to detect the fox as a 92% accuracy. I mean, confidence level. And you can even just just clear. You can play with it if you are interested. I think this one is one too. This one didn't work that well, I guess. See, this one is very blurry. You can see this is very blurry. So it has a coyote and the fox is 78%, the coyote is 62%. I'm glad you ignored the shadow. You wasn't ignoring the shadow before, so I had to add some shadow images as a background images.
Does it also have cat in the classifier?
No, I don't.
That's okay. Like, that almost looks like a cat. so
Yes.
that would be impressive.
Yes. No, I don't. It doesn't have a cat.
Maybe mistakenly got a cat.
Yeah, maybe.
Yes, you can. False positives. It happens all the time. So this is something, if you are interested, you can play with. This is super tiny fox here, you can see. Fox. Yes, who knows? Yeah, right now it's detecting 94%. Yeah. So, I mean, even though the soldering is so bad, but it's still working. So,
For the image categories, do you have like the other categories?
Yeah.
So
Background.
okay.
Yes, background images. That's including the chickens, the duck, and goose, the trees, the grass, the skies, the shadows, the cars, the cat. Actually, because we have bunkers, so actually I include some cats. The robot mower, all those images have. So
Is it thermal pattern?
A little bit about.
What?
What's the blue sticky for? There's no fin?
a cooling pad.
Okay. You didn't need any fins or anything like that?
No, I have. I didn't install them yet. Yeah, this is working for now. It's like a.
Is that a 0 or 02?
Hmm?
Is it a 02?
Zero W, I think, right?
0 W?
Which one? Which?
Is it a Pi Zero W?
A Pi 02W. Yeah, it's sold out. If you even if you want to buy it, you can't buy it because it's sold out.
Your edge protection? I mean, your detection. Yeah, you mentioned earlier you were building FP16. Reason why I asked.
Increase to like a FP32.
Picos and survive on it. It's full FP4.
I tried 32 and the 16. They didn't make any differences. The result is the accuracy, result the precision.
There's like a smaller, there's a dual core CPU. I think it can
Okay.
0. It proves the floating point.
Maybe limited.
A RISC-V and an ARM core. It's called Pico. It's made by Raspberry Pi.
Okay.
3 of them.
Is the sidecar that gets under the P0?
I've read that it can be attached via I2C, but it's like kind of scanning. It doesn't have a GPU on it.
GPU.
It does have, supposedly RISC-V is a better floating point than it.
Yeah, why not?
Maybe it's cheap and.
Yeah.
And
People
it
like
could
the
have done,
basic,
like,
the goal
really
is-
basic stuff like
When I see this
FP4,
project,
yeah.
I'm thinking like,
represent-
like,
I think it should stay in 4 and stay lower.
it's one thing here in the United States.
Guys, are we having like internal questions? Can we stop the recording? Ah,
Verified mingling, yes.
okay, I'm stopping the recording. Is it correct?
Yes.
Yeah. Okay, I'm stopping. Thank you very much.
Thank you.
From a business perspective,